Today, we're going to learn how to generate Huffman codes using a binary tree. Hello, I'm James Helfrich. The story behind Huffman codes is really interesting. There was a professor named Dr. Fano, and he was teaching a class on mathematics to a bunch of students, and he decided just for fun to give them a problem that he didn't know the answer to himself. In fact, it's an unsolved problem that he was currently working on and didn't quite have a solution. So he just gave it to his students and said, good luck with it. One of his students was named David Huffman. And David Huffman kind of liked the problem and thought about it a little bit and came up with an original solution. And that solution turned out to not only solve the problem, but be the optimal problem. And Huffman codes are that problem. So let's learn how to create Huffman codes using a binary tree. Let's first talk about the problem. We like to encode an alphabet of tokens with the smallest number of bits possible. The trick is that each of the tokens have a different frequency associated with it. In this example, A is used 20% of the time, and E is used 45% of the time, and B and C are only used 10% of the time. Since E is by far the most commonly used, we like to use the smallest number of bits for it. So the smallest number of bits we can use for this alphabet is 0 for E, and A would be 111. Now, how are we going to do that? Okay, what we're going to do is we're going to have a collection of binary trees. And each tree is going to represent the frequency of the tokens associated with it. So in this case, I'm going to start with 5 binary trees, and each binary tree is going to have a single node, the root node associated with it. A is going to be 0.2, which is the frequency associated with it, B 0.1, C 0.1, and so on. Okay, the first step of the algorithm is to take the two smallest frequency nodes, B and C, and combine them. So now I'm going to have 4 binary trees. One of them is going to be A, which we had before. And then we'll have a new node, which is unnamed, but it has a frequency of 0.2, which is a combination of B and C's node, and then E, and then D. So once again, I'm going to combine B and C under a single binary tree. Now I have 4 binary trees, A, 0.2, the unnamed one, 0.2, E, and D. Now, what are the two smallest frequencies? Well, that would be A and D. So I'm going to combine them with each other as well. So now I have 3 binary trees. The first one contains a node D and A. The second one controls B and C, and the third one contains E. Now, what are the two lowest frequency binary trees here? 0.35 and 0.2, and I will combine them as well. Notice how the new root is going to have the combined frequency of the two children it's assumed. And then finally, I'm going to combine the last two into a single binary tree. When I only have one binary tree, we know we're finished. Now we're going to assign a bit value to the left and the right child of each of these nodes. So between the root node and E is 0, between the root child and the 0.55 frequency is going to be the 1. Now, where you can derive the Huffman codes following the path from the root to each node. So A, how to get to A, is going to go right, which is 1, right, which is 1, right, which is 1. So it's 1, 1, 1 for A. For B, we go right, and then left, so 1, 0, 0. C, we go right, and then left, and then right, so 1, 0, 1. D, 1, 1, 0. And notice E is really close to the top. It only has a single value, which is 0. Okay, let's do the problem again. Now we have alpha, beta, gamma, delta, and epsilon with different frequency values. So once again, I'm going to create 5 binary trees, one of them for each of the values. So we're going to take the two lowest values, which is delta and beta, and we're going to combine them, and we'll put them in delta's spot. So now we went from 5 trees to 4, and notice how the new root for delta and beta is the combined frequency of both of them. Now the next two lowest is the new unnamed one and epsilon, and I'm going to combine them and put them in epsilon slot. So now we have 3 nodes, alpha, the binary tree, and then gamma. Now alpha and gamma will be combined. 0.25 and 0.30 becomes 0.55. And then finally, I'll put these all into their tree where the smallest frequency goes on the left. Now from here, I'm going to assign 0 for the left child and 1 for the right child. And once again, I'm going to find the path from the given node all the way to the root. So for alpha, it is 1, 0. For beta, it's going to be 011, for gamma 11, for delta 010, and epsilon 00. If you'd like to learn more about Huffman codes, take a look at example point 5.3 and the Huffman codes example, all in the C++ data structures textbook.